यानी गुड इवनिंग बेटा. Saran, good evening. Shivavni, good evening. Fine. Let's start the class. Shall we start the class now? Just 1 minute. So last class we were discussing about effective nuclear charge. In last class we discussed that what is nuclear charge, and after that we learned what is effective nuclear charge, and then we have understood shielding or screening effect also beta. Can anybody type and say that what is exactly nuclear charge? The attractive force, I'm just repeating, see, from the nucleus the proton releases an attractive force for the electron, that is exactly called as nuclear charge. Fine. So that was the first thing we have discussed in yesterday's class. Now what we are going to do today is we are going to understand the next important properties. So now what we are going to do is we are going to understand the next important properties beta. So what and all are the next important properties we are going to understand is atomic radius, ionic radius, and in atomic radius first thing in last class we have discussed about Nandini, good evening beta. In atomic radius we have discussed that ki the radius means the exactly distance between the center of the nucleus to the center of the valence electron will be exactly called as atomic radius. Okay, and after that we have learned that Okay, S Kamya, good evening beta. Nandini, good evening. After that we have learned that it is difficult to find the atomic radius. What was the two reason behind CBSE question? What was the two reason behind okay, thank you Kamya, thank you Aini. What was the two reason behind finding the atomic radius is difficult? Just yesterday itself I have asked this question. So now tell me the answer. What is the reason because of which finding the atomic radius is difficult? Finding the atomic radius is difficult. Vatsan, good evening beta. Finding the atomic radius is difficult. Come on, start typing, because see, look here, once I will meet you in offline class and I will ask all these questions, and that time if you will keep your mouth shut, I will really be very angry, because board examination is coming. So you have to be very attentive. Offline, online, anything. Absolutely correct Kamya, but two back-to-back points I have discussed. What is the basic point? See, isolated atom, isolated existence of isolated atom. The atom in the isolated state is very unstable. So that is the correct point what you are saying, and no sharp boundaries. Very good. In short, you have explained the 2 points. So I am just going to explain this one, that finding the atomic radius is difficult because of 2 important reasons. First important reason is, so I just have to check that down the group which one I am discussing, trend in periodic table across a period. And then important points, I think van der Waal, this point, atomic radius only. This topic is about atomic radius. Down the group, down the period, across the period, atomic radii. Yes. So this is the exactly cannot be isolated. So the most important point is that across the period, when we grow from left to right, so atomic radius keeps on decreasing. Atomic radius keeps on decreasing. So metallic radius, can you say again auntie? Yes, I am going to teach you metallic radius one more time. Yesterday in Haribari I have just discussed that point. So today I need to discuss that point in much detail. So I am going to discuss everything in details. I will not rush today. Now one by one I will be discussing beta. What is atomic radius? So atomic radius is the distance between the center of the nucleus to the center of the valence shell electron. That will be exactly called as the atomic radius. Now what will be exactly the atomic radius? So atomic radius decreases across a period from left to right. The alkali metal present on the extreme left have the largest atomic radius, while the halogen present on the extreme right of periodic table has the smallest atomic size. So this is what last class we were discussing about, that what happens when we go from left to right in the periodic table. So across a period, what happens to the atomic radius? This was exactly the point, that when we go from left to right in a period, what happens to the atomic radius? Then we came to the conclusion that atomic radius keeps on decreasing across a period. Across a period means कि from lithium, then beryllium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. On going from this part, we have seen one thing, that the structure of the atom keeps on exactly getting smaller. Okay, so why the structure of the atom keeps on getting smaller? What is the reason behind? The reason is, in the same orbit, the electrons keeps on getting filled up. The electrons keeps on getting filled up. So now same orbit electron keeps on getting filled up. So nuclear charge is exactly attracting the electrons of the same orbit. So what happens? It will exactly make the orbit bit smaller, and because of that the atomic radius will keep on reducing on going from left to right. Okay Kamya, absolutely correct. So now we are just going to see that yesterday itself we have seen this point, that lithium is there. Lithium outermost orbit, 1 electron will be there. Then after lithium, beryllium, outermost orbit, 2 electrons will be there. Same orbit, 2 electrons. In the same way, lithium, beryllium, boron, carbon, nitrogen, oxygen. So till it went towards fluorine, Now fluorine, what happened? Same orbit, it will go from there to there. So when I am talking about fluorine, what happens? That outermost orbit 1, 2, 3, 4, 5, 6, 7. 7 electrons are there. So now what happened comparatively to the size of lithium? We are seeing that fluorine size will be bit small. What is the reason behind the size of the fluorine to become small? Because same second orbit, the electron numbers are increasing. The effective nuclear charge hold on the electron becomes increased, and because of that the size will become a bit shrink up. So the size, the orbit, it will become bit near to the nucleus. Because of that, when we go from okay, sharp mesh will absolutely beta sharp at 8 I am going to start. So on we go from left to right in the periodic table, atomic radius decreases. Okay, atomic radius decreases on Kaushika, good evening. Atomic radius decreases. I hope everybody understood this point. Now what is the explanation in examination you have to write? If you are drawing, it is a very important thing. It is a very good thing that with drawing you are explaining. But what should be the apt explanation you are going to give? So, and that explanation point you must underline also. That is, across a period with increase in atomic number, the number of electron increases but number of cell remains same. That is, I told now, second cell electron numbers keeps on increasing. Second cell electron numbers keeps on increasing. Okay, so due to which the electron fill in the same cell, which in turn increases the nuclear force of attraction between nucleus and electron of the outermost cell, and thus atomic size decreases. That is the reason I also told that the electrons and the nucleus, the attractive force increases, which will shrink the size of the atom. And this is the reason behind when we are going from left to right in the periodic table, the size of the atom keeps on decreasing. So atomic radius keeps on decreasing on going from left to right in the periodic table. The reason is same cell or orbit filling of electrons. Okay, filling of electrons reduces the size, because one particular word after writing you are going to underline, that is attractive, that is nuclear force of attraction. Increase in nuclear force of attraction. So what word you are going to underline? Increase in nuclear force of attraction between the electrons and the nucleus. Between the electrons and the nucleus. This should be your highlight point. So if they will ask you, this point you must have to be writing. Okay. We are going to go for the, I think I should cancel today's class. Best I am going to cancel today's class. So I think no one is interested to study right now. See, 7:15 it is there, and how many of you have joined the class? How many of you have joined the class? What is the time right now? It is online class, so there is no problem behind attending the class late. So better I should not keep the class. If there is no interest in learning, why I am wasting my time? I should teach other batch. That will be better. And same question when I am going to ask in examination. Now if I am going to ask before, they will not be able to answer. Then they will say, Auntie, one more time explain please. I was not there that time. Then what explanation I am going to give? I want to save the time. I just have to give a final revision. What is going on here? Don't check my nerve system. I'm not checking I'm well or not well. I'm doing my work. You can't be present and listen to the part. That is the big problem for you. Last phase doing all this. I know some children, they are very, very attentive. They are attending the classes. Kamya is there, Akshaya is there, Kavya is there, Nandini is there, Shri Bhavani is there. They will attend the classes regularly. Vatsan is there. What about the others? Not interest. So I am going to cancel the class now. I'll send the notes better. You study on your own. From here after I am not going to teach. Today is the last class. So down the group. So now we are going to talk about down the group part. Checking my nerve, I will check your nerve. Wait. Written exam is coming. I am feeling the pressure, but you all are not feeling the pressure. Trying to give my best so that you will get the best. I will meet you all in offline class. That time if I will see that performance is not coming, that time only I am going to ask, where were you that time? Just wait and watch. You do this, I will also do the same thing. Atomic radii increases down the group from top to bottom. So when we talk about the size of the atom, atomic radius size, then we say that on going from top to bottom, the atomic radius is increasing. Can anybody explain the point why the atomic radius is increasing on going from top to bottom in a group? Tell him to join, no problem. I am also having network issues, but I am taking the classes. Rules are equal for everyone. Network issue means afterwards he can see, but right now he has to be present. Now look here, atomic radius increases because once whatever doubt is there, ask now. When we will start revision, that time I will not have time to explain everything from the beginning. Understand my position also, my situation also. I cannot sit there and stand there and explain everything from the beginning, every time. Morning time, same problem. Evening time, same problem. You become the boss. Very good. And if score will come less, then directly it is coming for me. Explanation, beta, what is the explanation behind the size of the atom, that is atomic radius increases down the group? What is the reason behind the increase in the atomic radius? What is the reason behind increase in atomic radius? Akshay is telling the answer that electron move more and more attraction shrinking. That is the previous one, Akshay, correct only. But when we go down the group, because period we have understood that period was on going from left to right, the atomic size is exactly what? The atomic size, the atomic radius is exactly decreasing. But when we go from top to bottom in a group, what happens to the atomic radius? Then you will be saying that, yeah, auntie, the atomic radius, how will it increase, auntie? It should be decreased, right? No, Kamya, on going from top to bottom in a group, total how many groups are there, Kamya? Total 18 groups are there. So on going from top to bottom in a group, one thing is exactly happening, and that thing is कि when you go top to bottom, every time one orbit keeps on getting added there. So you have to see that कि when you are exactly going from hydrogen is exactly having one orbit. Now lithium is having exactly 2 orbits. So now here 2 shells we can say, and here lithium, and then helena, that is sodium, is having exactly 3 orbit. Electronic configuration, outermost orbit 1 electron will only be there, but every time 1 new orbit will be exactly added. So what happens here is that is shielding effect or screening effect. What is exactly, what word I have used? Good evening, Nitesh, good evening. So exactly what is happening here is the screening effect or shielding effect is increasing. Now on going down a group for atomic radius, the screening effect or shielding effect increases. Then you will say, auntie, what is exactly screening effect doing here? Now you have to understand that the more the atomic size will increase, that means inside electron number is also increasing. So these electrons will hinder the attraction between the nucleus and the outermost cell electron. So this is exactly called as shielding effect. The outer electron attraction with the nucleus will become less because of shielding effect. The electron present inside, they will do screening. Screening means they will repel. There will be a repulsive force. So this repulsive force will try to Yes, understood, auntie. I didn't notice increase in orbit. Yes, so this increase in orbit will be there. So increase in orbit will do one specific work. The increase in orbit will exactly give the tendency to lose electron easily. Okay, so here we can see that because of shielding or screening effect, the size of the atom keeps on becoming bigger. So atomic radius increases down the group. Atomic radius increases down the group. Atomic radius decreases in the period. In the period, atomic radius decreases in the period, increases in the group. So this is what we were discussing about, that is atomic radius. Fine. So now beta, we are going to go towards the next important thing, and that is we are going to study about Ionic radius. So before understanding Ionic radius, so period I think we have discussed. Now we are exactly explaining about, we are going to understand period and group I think we have discussed. So now we are going to talk about a very important point. This is a CBSE question, and this question, if they will ask, what answer you are going to give. So the question here is ki what happens when, see, suddenly there is a decrease in atomic radius from lithium to fluorine, but suddenly when we are going towards noble gas, then suddenly the atomic radius increases. What is the reason behind increase in atomic radius? The question is, what is the reason behind? So why the atomic radius of fluorine is less, but atomic radius of neon, that is after fluorine, exactly neon will be there, it's exactly its atomic radius is bigger. What is the reason behind it? What is the van der Waals radius? Absolutely correct point. I'm going to discuss about van der Waals radius. So explanation, they are saying that, now I'm going to read out, atomic size of noble gases are larger than that of halogen, although they are present after halogen. So 100% we know in the periodic table, after lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon is there. So the atomic radius decreases from left to right. The atomic radius decreases from left to right, but suddenly after fluorine there is an increase in the atomic radius for noble gases. There is an increase in the atomic radius for noble gases. What is the reason? Stability is one of the answer. Stability is one of the answer, Shiva, but you have to explain that point perfectly. So what is the explanation? What is the perfect explanation? You are going to say that comparatively filled valence shell. So stability, how stability is coming? Because the valency is 0. So that is octet rule. According to the octet rule, exactly the last orbit is completely satisfied. There is valency 0 means it is having completely filled valence shell. So outermost orbit is completely filled. Okay, so octet rule is satisfied. So consisting of octet of electrons of noble gas are monoatomic molecule. Please kindly remember this point, that noble gases are monoatomic molecule. I want you to write this in examination. The most important points, that's why explanation I have written, so that this explanation when you will be writing in examination, you should underline the most important point is octet rule satisfied. Here valence cells are completely filled. Valence cell, key point. Valence cells are completely filled. Noble gases are monoatomic gases. They can exist in nature in free state. So these are the most important point you have to write. Okay, these are the most important point you have to write. You have to say monoatomic molecule. What answer you are going to say? Monoatomic molecules. So noble gases are monoatomic molecule. Monoatomic molecules are what type of molecules? Those molecules which exist in nature in free state. They are called as monoatomic molecule. Helium, neon, argon, krypton, xenon, radon. All these noble gases are exactly monoatomic molecule. They can exist in nature in free state. This answer I want. So therefore, in case of noble gases, atomic radius refer to van der Waals radius. Atomic radius refer to what? Van der Waals radius. Discussed yesterday what is van der Waals radius. See, if I am existing in free state, I don't want to combine with anyone. See, look here, when I will make a bond, when I need electron, when I need to share electron. So now I am going to explain van der Waals radius and covalent radius and metallic radius one more time. Okay, so listen to this point very nicely. In any one of that will come in examination. If I will ask in oral question, because oral question answer session will be there also. So when I will ask this, I want only point answer. I don't want any nonsense there. Fine. So because preparation has to be perfect, I will be asking these questions also. So now let's check that one. Last time again I am discussing about all the different type of bonds and radius formed. Yes, so last class we were discussing about everyone. Madhumita, this is a very perfect time to come in the class, beta. I am only the fool, the foolest person in the world who is not seeing that what situation is there. I am just thinking about all of you and you all sleep right now. No need to study. Before 1 week of examination, we will wake up now. We will wake up. At that time now, I will have one stick. I will go in your home and beat if less score anybody will get. I want perfect score. I am mad about it. And I want my children to be best this time. I will not listen anyone. I am telling again and again. I will see only best performance and best performance. I will not see anything. This, that, no reason behind. So now look here, beta. Understand there will be different type of bondings. You know how many different type of bondings are there? Then you will start answering the question. You know, auntie, covalent bonding is there, ionic bonding is there, metallic bonding will be there, and you know, auntie, coordinate bonding is there, then van der Waals is also there. So different type of bonds will be formed. Okay, no, I'm not going to listen anything. From tomorrow maths final revision I am starting. Morning, what I want to see quadratic or which chapter I am going to start. First 2 mark question I am going to discuss. CBSE last 20-year question I am going to throw from tomorrow. You be not attentive. The moment offline class I will meet, I will call all of you and insult very badly. Right now you are not coming in my grip now, but writing test you all will come. So that time I will not leave any one of you. Personally I will call you and tell you to solve a question, which I am going to discuss from tomorrow. I am not going to leave anyone. Score means score. I want 40 means I am 40 about it. I am mad about getting 40. 40 means 40. My children are best and they have to get the best. I am very angry right now because I am discussing very important point and see. Now look here, beta, covalent radius, metallic radius, van der Waals radius. So different type of bonding is there. According to the bonding, when 2 atoms are coming near now, they will be exactly having some attractive force, and with that they will form a radius. So that will be exactly called as covalent radius. So now covalent radius means what here? Kamya, now look here very nicely, beta. Kamya, everyone listen to me very nicely. I am talking about chlorine and chlorine. You see, the outermost electron cloud, the electron cloud of the outer valence shell, na, when they will be exactly coming together, you see how the electron cloud are exactly merging with each other, and see here the radius will be formed like this. This is exactly called as covalent radius. The non-metals are exactly combining and then they are exactly making a compound. Here is a share of electrons taking place. So the bond will be formed here. It is called as covalent radius. So it is defined as the distance between the 2 atoms bound by single bond in the molecule. It will be coming as covalent. Absolutely, it is coming for halogen. Kamya, understood? Now next here I am just discussing in chemistry, van der Waals force radius is measure of the size of atom that is not chemically bound. So definitely we know that the atom will not be chemically bound. So if I am a noble gas, I don't need to combine with anyone. So if I am going to find me and my friend, there will be gap between me and my friend. So definitely my radius will be bigger in compare with that of covalent bond, because you see here in in covalent bond, for making the bond, what they are doing, they are coming close. Now the next one is, you see here, for covalent bonding, the atoms are exactly, the clouds are merging with each other. Now you see here for metallic bond, see metallic bond clouds are not merging. What is the reason behind? Because metallic bonds are exactly formed between ions and electrons. Ions and electrons. So I am going to discuss about metallic bond. Now van der Waal, you see, if I am talking about neon and neon, see there is a gap between them because they need not to combine with each other. They are not forming any bond. Now ionic bond, if I want to say that, in ionic bond there is a transfer of electron. One will give electron, another will take electron. That will be the strongest bond forming there. So there also some bond length will be there, radius will be formed, but in compared to them it will be exactly there. So now here you see van der Waal attraction. Now metallic bond, you had doubt in metallic bond now. Now I am going to discuss about metallic bond. But a metal and metal can also form a bond, because when you are seeing copper, you are not seeing only one copper small particle. You will see combination of copper, means if you will take copper, pure metal copper, then one particular size of copper you can take in your hand. So now when you are taking that, all the copper molecules are exactly, atoms are combined, so there must be some bond formed between them. So how the metallic bonds are formed? So now look here, from between two metal atoms, metals and metals, the bond will be formed is called as metallic bond. Now that metal can be same element or metal can be different element. Okay, now how this metallic bond is formed? That's why now alloys are formed, beta. What is an alloy? Alloy is a mixture of element. Alloy is a mixture of element. So we can form alloy. Steel is an alloy only. Nichrome is an alloy. So when other metals and metals are combining, then they are forming alloys now. So how these metallic bonds are actually formed? So the atoms are unstable. They do not have full electron ring. So these metallic bonds, the atoms are very unstable. They don't have the full electron rings also. So what they are doing? So to stabilize them, they do something. So what they are doing here is bond by sharing very loosely held valence electron with each other. So they are exactly forming a metallic bond. How they are forming a metallic bond? By the electrons present in the outermost orbit and their ions. Electron present in the outermost orbit and their ions, they are forming a metallic bond. Okay, so the electrons flow between the atom. Now just understand this situation. The most easiest way to understand is, now understand sodium. Now sodium is there. Now sodium wants to gain the nearest noble gas configuration. So sodium become like this. Now, if sodium will not get any electronegative element or any electronegative element, if sodium will not get, then what sodium will do? Sodium, another means, if I am going to take a vessel and in that I am going to keep sodium, then sodium ions will be there and electrons will be there. So these electrons and these sodium ions, they will exactly, these sodium electrons and ions, they will be exactly presenting each other. So they are present here inside. So now a bond will be formed, a weak bond will be formed between this loose electron and this sodium ion. So that is exactly called as metallic bond. That is exactly called as what bond, beta? That is exactly, auntie, can you have not started revision for electricity chapter? No, auntie. No, very soon I am going to start electricity chapter revision. At the time of revision, I will not be listening anyone, Madhu. That time I will be a different person. Today you have seen my anger. If you want, you can see my anger in offline classes and online classes. I am not going to be the same person. I know if I will not be strict, you will not be gaining score. You will become loose. So that time I have to be very strict. From tomorrow maths class, you will see my situation. I am very in panic mode. I want full mark means full mark. I am mental about it. Okay. So now beta understood. Kamya, please kindly say you had problem in metallic bond. I hope now everything is exactly clear. Can we see the metallic bond? You see beta, copper can lose 2 electrons. So now copper is losing 2 electrons and it is making Cu2 plus. Now Cu2 plus and the free valence electron, it will exactly move in this ion. So ions and electrons, they will make a very they will make a very loose bond between them, and this bond is exactly called as metallic bond. This bond is exactly called as metallic bond. Okay. Now, metallic bond consists of attraction between the free floating valence electron. I repeated the most important point, free floating valence electron with free floating valence electron positively charged metal ions. So, copper ion and electron. And this is what I have showed you also, that is, see here, sodium when releasing one electron, now this sodium ion and this electron will be exactly forming a metallic bond. So bond between ion and electron is called as metallic bond. That's it. That's it, Kamya. You have exactly said the most important point. This is the most important point, that bond between the ions and electrons are exactly called as metallic bond. It will be the weaker bond, beta. It will be not the stronger bond. It will be the weaker bond. Okay. So you have one word, the necessity is the mother of invention. So here exactly necessity is to combine and stabilize itself. So when they have nothing to stabilize, they want to stabilize themselves by their ions and electrons, okay, by forming metallic bond. See, so what is metallic bond? So metal atoms are arranged in large lattice. It contains positively charged metal ion and negatively charged electrons. Which type of electrons? Inner cell electrons or valence cell electron? The answer is valence cell electron. Good evening, Rahul. Rahul, I will go in your home. This week I am coming to your home. Wait. I will have a final call with your parents before examination. Metallic bonding is the strong attraction between positive metal ion and sea of delocalized electron. You can see the delocalized electron which moves in this positive ions. So this is exactly called as metallic bond. So metal bond is there, sir. Again you are going, so metallic bond will be metal ion bond. Please kindly contain this, understand this point. So metal ion, metallic bond consists of attraction between the free floating valence electron. So exactly the free floating valence electron and the metal ion will be trying to stabilize the instability. So they will be exactly forming. Remember this point. So metallic bond has been, that is metallic radius will be coming. You see here, we are talking about metallic bond and metallic properties. So look here. So see here, metallic radius, metallic bond, we have discussed about metallic radius, atom, metal will be there, but who is stabilizing it? The stabilizing part is exactly coming because of the electrons, the bond between the electrons, the loosely, freely moving electrons and the positive ions. Okay, and the positive ions, metal ions and electrons. That is what, Sudarshan, and that will be the key point, beta. Remember that key point. Now shall we go back to our class where we were discussing about van der Waals. So if somebody will, this is a CBSE question right now which we were discussing. So now we were discussing that why the noble gas size is exactly, atomic radius is bigger in compared to that of halogen. The answer is the noble gases are monoatomic gases. Their outermost cell is completely filled. So that because of that they can exist in nature in free state, and that's why in case of noble gases atomic radius referred to van der Waals radius, while in case of halogen atomic radius referred to covalent radius, and that is what I showed you, covalent and covalent bond forming between two covalent between two halogen family, between two halogen elements. You have seen now that chlorine and chlorine is exactly forming a covalent radius. Okay, so and by definition of van der Waals radius, any element, the van der Waals radius for any element will miss, if any element is having van der Waals radius, then that radius will be larger or bigger in compared to that that of, or more in compared to that of covalent radius or metallic radius. Okay, so it will be comparatively more. It will be comparatively more. This is the explanation. When I will ask this question, or CBSE will ask this question, you are going to write the question with appropriate underlining. Okay, so that's why along with question I have given explanation also. So now the next question there is what is exactly ionic radius? Now first understand what is ionic radius. So atomic radius you have understood. Now we are going to understand what is ionic radius. So basically there are two type of ionic radius. One is cation and one is anion. So what is a cation and what is a anion? First you have to understand that one. So ionic radius and property of ionic radius. So ionic radius means, you know that the elements in the periodic table, they are very unstable. Okay, so there is exactly, the periodic table is divided between two family, metals and non-metals. So the periodic table is exactly, and between metalloids are there. Metalloids are there. So now between metals and non-metals, what is exactly called as ionic radius? So you have to understand that metals always want to lose electron, okay, and to gain the nearest noble gas configuration. So to do this, what they are doing is they are releasing electrons. So if I am going to talk about lithium, then lithium will release one electron and it will become Li. Okay, so this is not only one case. Magnesium will release 2 electrons and it will become Mg2 plus. So it will release 2 electrons. So we know that metal have a tendency to lose electrons. Metal have a tendency to lose electron. So when metal will lose electron, they will be exactly called as cationic radius. So they will be forming cations. What they will be forming? Cations, cations. What they will be? Cationic radius. What will be there? What radius they will have? They will be exactly having cationic radius. They will be having cationic radius. Means when an atom loses its electron and becomes an ion, then the radius what they will have, it will be called as cationic radius. Okay, what radius it will have? Madhumita, van der Waals radius will only be for noble gas. Yes, the gases which have the capability to exist in nature in free state, monoatomic gases. Monoatomic gases, beta. Monoatomic gases. So specifically, I have told you generalized statement. So you can take the example of noble gas. So when you will be talking about van der Waals radius, so you will be saying that those elements which have the capability to exist in nature in free state, like noble gases, they have van der Waals radius. They have van der Waals radius. This answer I want from you. Now look here, beta. So cationic radius means when an atom loses electron, then they will form what type of radius? Cationic. So now what is anion? Anion means when gain of electron will be there, then it will be called as anion. Okay, when gain of electron will be there, it will be called as anion. All the non-metals, they need electrons. They need electrons. So let us take chlorine. Chlorine is exactly doing what? Chlorine is getting one electron. So chlorine need an electron. Chlorine is needing an electron. Since chlorine is needing an electron, chlorine is needing an electron. So it will become Cl minus. Chlorine is needing. So what will happen when they will get electron? So the structure will change. The structure will change. The atomic radius, the ionic radius, how the ionic radius will respond, that we are going to see now. How the ionic radius will respond, we have to see that. So I hope you might have understood what is cationic radius. So for a basic point, remember, till this PDF will not reach to you, just remember this basic point, that cationic radius means metals are exactly cations and non-metals are anion. The one which is releasing electrons, they will have cationic radius, and the one which is gaining electron will have anionic radius. Okay, so ionic radius means the metals will either lose electron or gain electrons. So when they will lose electron, they will have cationic radius. Repeat this point. When they will gain electron, they will have anionic radius. When they will gain electron, I am repeating my point, when they will gain an electron, they will have anionic radius. I repeated this point. When they will gain electron, that will be exactly anionic radius. So cation and anion, I hope you might have understood. I hope. Yes, it will gain means anion, it will lose means cation. Okay, gain anion, lose cation. Gain anion, lose cation. Okay, I hope you might have understood. So now let's see this specifically. So it is the effective distance between the center of the nucleus of an ion, not an atom. Ion. Ion means what? Sodium ion, chlorine ion, sodium ion, sodium ion, chlorine ion, magnesium ion, okay, lithium ion. So we are not talking about atom, we are talking about ion. The distance between the center and the outer ionic form, that will be exactly called as ionic radius. So that is what I am exactly going to discuss is, it is the effective distance between the center of the nucleus of an ion up to the center of outermost cell electron. Center of outermost cell electron. Metal cation, non-metal anion. Very good, Madhumita. So lose electron, cationic radius. Gain electron, anionic radius. Key points, please. Sudarshan, I want the best answers from all of you. Okay, I'm very now, I'm going to a very Vera level confusion, like last time itself I'm getting this, what you call, heartbeat ready, because the more your examinations are coming near, the more I'm having like I have to sync everything, and maths and sciences score has to be the best. That I know, that I am going to do. So cation have smaller radius. The cations are having smaller radius. Why cations are having smaller radius? Who can answer me? Why cations are having smaller radius? Why cations have smaller radius? They are saying that cations are having smaller radius as compared to their parent neutral atom because of loss of one or more electron from the atom, but the number of proton remains the same in the nucleus. But the number of proton remains the same in the nucleus. Because of that, what happens? I'm just going to discuss this part, lithium section, and P/E ratio I'm going to discuss. Okay, so now I'm going to discuss about what is exactly cationic radius. What is exactly cationic radius? Auntie, this is possible for element for undergo only ionic bond. Now look here, beta. You have to understand one thing, Sudarshan. There is a game in the periodic table. The game is losing or gaining. And beta, there is a case of reactivity where they can share also. Beta, you know that non-metals are sharing. They are making covalent bond also. So beta, when different type of bond will be formed now beta, so cationic or anionic radius will be totally based on giving and taking. Cationic radius and anionic radius, when we talk now, we will only talk about giving and taking beta, because until and unless an element will not be losing electron, they will not be forming an ionic part. Okay, so when we are talking about ion, means electron has to be released or electron has to be taken. But there are certain metals in the periodic table, they love to share, like carbon. Okay, so like carbon we are talking about. So that case also we have to check. Carbon means valency is exactly 4. That time it will be a problem. So they are less reactive in compared to that of anion and cation. Okay, they are less reactive in compared to that of cation and anion beta, because gaining 4 electron and losing 4 electron is not possible for such element. Fine. So but that's why we are talking about cation and anion. Look my hand. Cation and anion means two different family. Metal family, non-metal family. In non-metal family, extreme left, and metal family, extreme right. So my right and my left. So they are exactly capable of making cationic radius and anionic radius, Sudarshan. I am not talking about the middle one, which are less reactive. When you will be going to the next level, I will teach you about reactivity or valence cell also. So periodic classification, next class I am going to talk about this also. So now we are going to talk about cation first. Now look here beta, lithium outermost orbit, here two orbits are there. First orbit 2 electron, second orbit 1 electron. Now lithium Li plus, only one orbit is there, 2 electron. So now tell me how many proton it is having. Here proton number is coming as 3. How many electron it is having? Electron number is 3. So proton by electron ratio is coming as 1. For lithium, proton by electron ratio is coming as 1. Now here how many proton is there? Inside the nucleus, number of proton don't change. So here proton is also 3 here, because only electron has left now. So now electron is coming as 2. So now proton by electron radius is coming, ratio is coming, so it is coming 1.5. So now lithium proton by electron ratio is exactly lesser than lithium ion proton by electron ratio. So when it is less, that means when the less means the main atom P by E ratio is less, that means it is showing that the size is smaller. When the ionic P by E ratio is big, that means size will be small. Size small. So cationic radius is less or smaller than main atomic radius. This you have to understand, means the main neutral atom was there now. So this structure is bigger and this structure is smaller, because the P by E ratio of this one is exactly bigger than this one. I hope you might have understood this point. This is a very important point I am discussing. With P by E ratio I am discussing, means after this there is no concrete proof. So this is exactly P by E ratio of an atom is lesser than P by E ratio of the ion of the atom. P by E ratio is exactly ion of the atom is bigger. So when this ion P by E ratio is bigger, that means ulta, its structure is smaller. So when P by E ratio bigger, structure smaller, just reverse part of it. So P by E ratio bigger, structure smaller, just opposite. Fine. So cationic radius, whenever cationic radius will be there, their size will be smaller than the respective atom. Understood everyone? Come on, quickly tell me. Kamya, understood? So this is exactly about cationic radius, and that is what they have discussed. So here this part P by E ratio is not mentioned, that's only. So just see, does ratio of proton to electron increase, effective nuclear charge increase and size will decrease. So increase in the effective nuclear charge, size will become small. Okay, that means once you are removing one electron, nucleus will become very tension. Hey, how can that electron go from me? Now nucleus was first taking care of 3 electrons. Now nucleus is only taking care of 2 electrons. So that means now same force one nucleus was giving for 3 electron. Now nucleus is exactly giving the same attractive force for remaining 2 electrons. So definitely the size will become small. So this is the underline point which I have discussed. This underline point I want you to write in the examination. Now next I am going to talk about ionic radius. So now ionic radius, I think cationic radius we have discussed. Now we are going to, that is the structure one. Now I am going to go for ionic radius. Now ionic radius is just ulta. Okay, in ionic radius what you are doing? Ionic radius, you are taking electron. So ionic radius taking electron means now for ionic radius, let us take example of chlorine beta. So chlorine outermost orbit, how many electrons are there? Outermost orbit 1, 2, 3, 4, 5, 6, 7, 8, and then here it is exactly going to be 7, 1, 2, 3, 4, 5, 6, 7, and here 2 is there. So total proton number is how much? Proton number is 287. 287 means how much? 2, 8, 10, 10, 7, 17 is coming. Electron number is also 17. So P by E ratio is coming as 1. But here chlorine is exactly doing what? Chlorine Cl minus. So Cl minus means 2 and then 1, 2, 3, 4, 5, 6, 7, 8 and then outermost orbit also 1, 2, 3, 4, 5, 6, 7, 8. So now P is coming as 17 only and electron is coming as 18. So now P by E ratio is 17 by 18. So 17 by 18 is less than 1 or more than 1? 17 by 18 is less than 1 or more than 1? Come on, quickly tell me. Yes. So when ionic radius will be greater than the atomic radius, then the size will become small. So now can you tell me here 17 by 18 is greater than 1 or less than 1? 17 by 18 is greater than 1 or less than 1? First answer my this question. 17 by 18 is less than 1 or greater than 1? (17 by 18 is less than 1 or greater? Super beta. So when 17 by 18 is less than 1, so what could be the structure? So since this ratio is exactly coming less, so what size you are expecting? Greater size or less size? It is working ulta na? It is working ulta. So anionic radius will be greater or lesser? Anionic radius will be greater or lesser? Come on, quickly tell me. Because cationic radius we have seen that there is a decrease in the size. So anionic radius will be absolute, Kaushika. That is the point. So Kamya, absolutely correct. The size will be bigger. It will be greater size. This is my point I needed to discuss, and I am really feeling like victory point because you have explained it nicely. So ionic radius is just opposite. Absolute correct, Sudarshan. That's why I was wanting all of you to be here. Because today I was knowing that I am going to discuss a very important point, beta. So now we have understood about ionic radius. Now there is a trend. CBSE will ask not this type of question. You have seen term 1 question. Now you will see the term 2 question. There they will ask you this question that down the group what happens to the ionic radius? Give explanation. Down the group what happens to the ionic radius? Now you know that cationic radius is exactly smaller than the what you call actual radius, and an ionic radius is bigger than the actual radius, but they will not ask this because they know that you will be answering this. You have understood this point, but they will ask you this question that down the group what will happen to the ionic radius? Then what answer you are going to say? Then you will simply say that down the group all cation, anion and atom itself, ionic radius, atomic radius, down the group increases. This should be your answer. Down the group, cation or anion, all radius is increasing. Down the group, cation or anion, all radius will be increasing. What answer you are going to write there? I am telling you, I am guiding you to write the answer. Don't write any rubbish there. So you are just going to say that we already know now कि the losing tendency of electron means the size will keep on increasing. The increase in size means the nuclear, that is the shielding effect will increase. So force of attraction between the valence electron and the inner nucleus will decrease. So this will exactly make the size bigger. So this concept will be containing for atomic radius or ionic radius. But cations are bit problematic. Okay. But one thing will be difficult, Sudarshan, when we talk about cation na beta, when we go from top to bottom na, their tendency to lose electron will increase. Because of their bigger size, they can lose electron easily, but gaining electron becomes bit difficult. Gaining electron for anions will be bit difficult, but though they are exactly existing as a bigger atomic size, so they will stabilize and they will maintain that. So, but writing part you are going to write, a cation is formed by loss of electron from the outermost orbit, which may cause of the complete removal of outermost cell, his size is much smaller than the corresponding atom. This is about cation. So cation size will be smaller, but though on going from top to bottom in a group, it will increase because of addition of orbit. Because of addition of orbit, stick to the point, please. So now we are going to go to the next one class. Now I am having another class, beta. I am having another class. So next I am going to talk about metallic oxide, I am going to talk about valency, I am going to talk about ionization, I am going to talk about many important points in tomorrow's class. Shell is being added up, that is one of the case, okay, that is one of the case. I hope today's class you might have understood. So just have a recap, let's see how much you have understood today. I am just asking one question, just tell me that answer of that 2-3 questions I am going to ask, so that I will see that you have understood this point or not. What is the basic difference between van der Waals radius and covalent radius? Basic difference between van der Waals radius and covalent radius. Covalent radius and van der Waals radius. Just say the basic point. I don't want to listen history. I just want to listen the most important point. Basic difference. Because I am having another class. But a basic difference. Basic. No here and there. Basic difference. Only one question asked. Absolutely, Kavya, nailed it. Basic difference is van der Waals radius is for monoatomic and covalent radius is for diatomic. Ah, super, nailed it here, nailed it, super. Monoatomic, diatomic. Kashika, Madhumita, absolute. This is what I was expecting. Van der Waals radius means it will be exactly talking about what? Van der Waals radius for monoatomic noble gases. That's it. Okay, monoatomic noble gases. So like this only I'll keep on asking questions when we will meet in offline class, and orally I will tell anyone to stand and represent the entire chapter. Okay, bye everyone.